Hello guys, you welcome to my channel. So today we want to look at another concept of physics, and it's very important, and that is the concept of velocity time graph. A lot of students find this difficult, how to represent motion of an object with a velocity time graph and how to interpret a velocity time graph. But before we look into velocity time graph, there are some certain factors that I would like us to consider and some certain things that we need to understand. Now, what are those things? We need to understand what is called distance, displacement, speed, velocity, and acceleration. Also, we need to understand what we call deceleration. So that we get this now. All these are the concepts that we have to consider before we start looking at the concept of velocity time graph itself. So are you guys with me now? Okay? Before we go on, if you are yet to subscribe to this channel, kindly do now, and like this video, drop a positive comment and share within your friend as well. Remember, we are here to learn together. So if you have any question, you are free to use the comment section to drop your question. Is that taken now? Okay, so let's go on now. If I'm to talk about the distance, what is distance itself? Distance. When you say distance, distance means the total path traveled. The total what? Total path traveled. Total path. Total path travel. Let's take for instance that I have a body A, that is, this is point A now. Then a body move from A down to point B, which distance is 4 meters. Remember, literally, distance is the what? The gap between 2 points. But why I don't want to use that definition is because I want you to remember the definition of distance, and you should be able to carry out any arithmetic on that distance. That is just the actual meaning of using what? This particular definition. That is the reason why I'm not using that. Distance is the gap between 2 points. Because if I say distance is the gap between 2 points, it won't help you to do anything arithmetic. Is that taken now? So by using that total path traveled, it will help a lot. Now, if a body moves from A to B, whose gap between A and B is what? 4 meters. Then this same body now move down to what? Down to C. And the distance between B and C is 3 meters. That is, the gap between B and C is 3 meters. The gap between A and B is 4 meters. Now, if the question now says, what is the distance covered by the body? Remember, the body starts from A and what? End its journey at what? C. The body moved from A to B, which is what? 4 meters. And move from B to C, which is what? 3 meters. Are we together now? So it says, what is the distance covered by the body? The distance covered by the body will be 4 meters plus 3 meters, and that will give us 7 meters, because that is the total path traveled. Do we get this now? The body traveled through this point and traveled through this point. So the total path traveled is 4 meters plus what? 3 meters. Do we understand this now? So that is what we call distance. Is that taken now? So even if the body should move up like this, down like this, if this is another 4 meters, and it moves back like this is another 3 meters. If they say what is the distance of the body, the distance of the body is just going to be 4 meters plus 3 meter plus 4 meter plus 3 meter, and that will give us 14 meter. So that is what they call distance. I believe we understand. Now, let's go to the next one, which is going to be displacement. What is displacement? You know, we always say displacement is the distance between 2 points in what, or the gap between 2 points in a specified direction. That is just literally the meaning of displacement. But that definition will not help us in carrying out what, any arithmetic on displacement. Are we together now? Now, for us to be able to carry out arithmetic out under displacement successfully, we have to define displacement as the shortest distance what, traveled. Are we there now? Displacement is the shortest distance traveled. Are we together now? So when you talk about the shortest distance traveled, we are talking about displacement. Is that taken now? Now let's go back to the previous example. If I have this, remember the body moved from A down to C. This is B, and here is 4 meter, while here is 3 meter. Now when you say displacement, remember that the body wants to move from A to C. And that is the reason why the body passed from here to this place, then from here down to the destination. Now, when they now says what is the displacement of the body, you are now to check what is the shortest distance that the body can travel to arrive at what? At C. Who can answer that? Okay? You will see that instead of the body moving down to this side, then now from here to this side, why can't it just move down like this from A to C directly? I'm not sure you get what I'm saying. That is, instead of the body now to move from A to B, then from B to its destination, why can't the body just move straight from A to C? That will save time. Because this is like a short cut. So the shortest distance is this, because this will save more time. And let's see if this will save what? More time. So let's see. Displacement. So using Pythagoras theorem, we have d square equal 4 square plus 3 square. So d square, this will give us 16 plus 9. D square equal 25. So you see that displacement is going to give us 5 meters. So you see, unlike distance, 4 meter plus 3 meter, that is 7 meter. It's quite long than what? 5 meter. So this is displacement now. Do you understand this now? So when you say displacement, it is the shortest distance traveled. Is that taken now? Okay? It can even come in another manner like this. Let's take for instance that a body starts from this point here. Okay? Look at what will happen here. If this is T, and this is A, this is B, this is C, and this is D. Let's say from here to this place is, from this point to this point here, let's say it's 10 meter. And from here to this place, let's say 5 meter. Here is also 5 meter. And here is, let's say here is 6 meter. Now, if a body wants to move from B, are we together? If a body wants to move from B to T, the body wants to move from B to T. Now, the body moves from here down to this point here. Then to this point here. Then to this point here. Before now coming down to T. Are we together now? You know, this will definitely be what? The distance. That is, the total distance covered from B to T is just A, so B to C, C to D, D to A, then from A down to T. That is the distance. So it means the distance is going to be 5 plus 6 plus 5, 5 plus 6 plus 5, then this will be 4, then plus 4. So you see now, it will take the body 20 meters. The total distance covered by the body is going to be what? 20 meters. Why can't the body just move from here down to this place? You know, this would be a very short distance for the body. Just move from B down to what? To T. And that will just give us what? 14 meters instead of what? 20 meters. The reason why I'm giving you this is that it's not in all cases that you are going to be having it to look in form of Pythagoras. You just check what? The shortest what? Distance traveled. That is what we call displacement. Is that taken now? Now, I think we have understand distance and displacement now. Now, a distance is what? A scalar quantity because it has only magnitude, no direction. Displacement is a vector quantity because it has both magnitude and direction. Is that taken now? Okay, if that should be the case, let's look at speed and velocity now. So when you talk about speed and velocity, if I say speed, is the rate of change of distance, the rate of change of distance, that is distance over time. If a body moves from here, point A to point C, if this takes 4 meters and this is what? 3 meters. Let's take for instance that for this body to move from here down to this place, are you getting this now? For this body to cover a distance of 4 meters, then 3 meters before getting to what? To C, it takes the body 2 seconds. If it takes the body 2 seconds, then the examiner now asks you that what is the speed of the body. If the body can cover a distance of 7 meters in 2 seconds, then what is the speed? So the speed is going to be this plus this, 7 meters divided by what? 2 seconds. And that will give us what? 3.5 meters per second. And that's the speed. Do you understand that now? The rates at which what distance change is what they call speed. It means for this body to cover this distance in 2 seconds, it means for every 1 second, the body cover a distance of 3.5 meters for every 1 second. Is that taken out? Now, what will now happen to the velocity of the body? For velocity is going to be the rate of change of displacement, in respect. How then now? The rate of change of what? Displacement. That is displacement over what? Over time. So, it means this will be the case. From A to what? To C. If the body moves from A to C for 2 seconds, then what is what? What is going to be its velocity? So we already calculate this to be 5 meters. So we then have 5 meters divided by what? 2. And that will give us 2.5 seconds. So if the body should use 2 seconds to move from here to this place, it shows that the body is covering what? This should be meter per second, sorry. It means the body is covering a distance of 2.5 meters in what? In 1 second. Do you understand this now? So that is that about speed and velocity. Now there's something we now call uniform speed or uniform velocity. When you say uniform speed, it means at every instance, let's take for instance that the body wants to move from here. If I have this, like this, if this is 3 meters, and this is also 3 meters. Now, if I have another one, let's say I have this is also 3 meters. I see it now. So, let's say this is a body now. When the body time is what? When the time is 0 seconds. Then when the time is 1 second, when the time is 2 seconds, when the time is 3 seconds. You see that for every 1 second, the body still covers the same amount of what? Distance, which is 3 meters. When a body covers the same amount of distance at every given time, that is, for every seconds, the body still covers the same numbers of what? Distance. The same amount of distance every second. That body is moving with a uniform speed. And a uniform speed on a straight line is equivalent to a uniform velocity. A uniform speed on a straight line is equivalent to uniform velocity. Take note of that. Because what? Distance on a straight line is equivalent to displacement on a straight line. Once the distance is what? Is regarded with a straight line like this, it will have the same value as what? As velocity, as displacement also. Sorry. Are we together now? Because once the direction is just straight, then there is no shortcut. Is that taken out? Okay? So if that should be the case, let's now consider their graph. Okay? So let's start with the distance time graph. Distance time graph. Now, when you call a graph a distance time graph, it means we plot what? The value of distance against time in seconds. This one is in meter. Are we together now? So, if I have a uniform speed like this, are we together now? So, if I plot the graph of distance against time, and I have a straight line like this, are we together now? This shows that what? This is a uniform speed. Are we together now? Now, if this should be the case, if I take the slope of this graph, the slope of this graph is going to give me delta S, and this will be delta T. So the slope of the graph is going to be speed, because this will be change in distance all over the change in time. Are we together now? That is, for distance time graph, the slope is always giving us what? Speed. And that is the only thing that we can determine using what? The distance time graph. The distance time graph can be used to determine what? Speed. Now, this is what? This is a uniform speed now, right? If the speed is not uniform, this is distance in meter, and this is time in second. The speed might not be uniform. That is, I can have something like this. You see now, I have a curve. How can I get the slope? I have to just draw a tangent to this what? To this curve. So the slope of that tangent is what will give me what? What will give me my speed. Do you understand this? Now, if the body speed is constant, a constant speed, this is distance in meter, this is time in seconds. For a constant speed, I have what? I have a straight line like this. Are we together? So I have what? I have this to show that this speed is a constant speed. And when a body is moving with a constant speed, it always seems like the body is not moving. Are we together now? It always what? Seems like the body is not moving when a body is moving with a constant speed. Do you understand this now? Okay. Now, let us now talk about the velocity of a thing now. That is the displacement time graph. This is this for distance time graph. Remember, this is not actually where we are going to. Our focus is to look at velocity time graph. But we have to understand all of this before we go into that. Okay. The next thing here is displacement time graph. For displacement time graph, For displacement time graph, we plot the graph of displacement of a body in meter by what? We plot displacement against what? Against time. When you plot displacement against time and we have a straight line like this, the slope of this graph is going to give us what? The slope of this graph is going to give us velocity. So, velocity is going to be the change in displacement over what? The change in time. Do we understand this now? Okay? And if it is a constant what? A constant displacement also, remember this is uniform. If it is non-uniform, the non-uniform can come in different form. If it comes in this manner, then the gradient, that is the slope, is said to be what? Is said to be 0. Are we together now? So, but if it comes, remember this is displacement in meter, let me use x, and this is time in second. And if it comes in form of this, it can also come in form of this if it is not uniform. You do the same thing by drawing what? A tangent to this. Remember, these are not our focus. Okay? So this is x in meter, and this is time in second. Are we together now? And when you talk about constant what? Velocity also. A constant velocity can also come in form of what? A straight line, just like we have it when we are talking about distance time graph. So if it is constant, this is displacement in meter, and this is time in seconds. So you have a straight line like this. So when the body is moving with a constant speed on a straight line, it's the same thing as when the body is moving with what? A constant velocity on a straight line. Don't forget that. Is that taken up? Okay? So that's that about what? Distance time graph and velocity time graph. And when you look at those two graphs, you see that they don't really give us enough information about the motion of a body. And that is why we don't usually look at them. I'm very, very strong earth-wise. I just have to make all this video. Pardon me. And let's just keep learning together. I believe I'll get back to my feet very well, very soon. Okay, so let's go. Now, if you look at, when we now talk about all these two types of graphs that I've mentioned, that is the distance time graph and the displacement time graph, you see that the only thing we are able to deduce from them is just one thing each. That is, for the distance time graph, the only thing we are able to deduce is just what? The speed. And for the displacement, the only thing we are able to deduce is just the velocity. And when you talk about motion of a body, a lot of things is to be considered, like the distance, the total distance covered, average speed, acceleration, retardation. How can we get that from the graph? That is the reason why we need to look at velocity time graph. Velocity time graph is very useful compared to any of those two graphs that I mentioned earlier, that is the distance time graph or the displacement time graph. Why? Because it can give us acceleration of a body, it can give us retardation of a body, it can give us the average speed of a body, it can give us the total distance covered by a body. Now, students usually find it difficult. That is, they always see it to be a problem. Why? Because at times, the motion of a body can give you different shape. A body can just be going like this now, and it can form a square shape. The motion of a body can form a square shape. At times, it can form a triangle. At times, it can form a trapezium. Are you getting it now? At times, it can form a rectangle. And even at times, it can combine the whole of the shape. Are we together now? Please note this and have it at the back of your mind. The motion of a body can form different mathematical shape. And what are the prerequisites you need? The prerequisites you need is just for you to know the area of each shape. How do you calculate for their areas? Remember, that if this is a trapezium, the area of this trapezium is going to be, remember, this is the height, and this is equivalent to this. If from here to this place, let me call it A and call this one what? B. So area of this trapezium is going to be 1 over 2h into what? A plus B. Are we together now? And if I have a triangle, this is the height of the triangle and this is the base. Area of this triangle is going to be half base times height. And if I have a square or a rectangle, let me call it a rectangle because a square is also a rectangle. A rectangle with equal sides is what we call a square. Note that today. A rectangle with equal sides is what we call a square. So, for a rectangle, we have that A, this is the length and this is the breadth. Remember, the longest side is what? Is the length. So, the length times the breadth is going to give us what? The area of what? Of the rectangle. Now, these are the common shape that can be formed. Now that we know the formula to calculate their area, we are good to go. Now, when do you use this? If you are asked to calculate for total distance traveled by a body using a velocity time graph, it's just as simple as you adding individual area of each shape. That is the summation of individual areas of each shape. Are you getting this now? That will give you the total distance traveled. For you to understand what I'm saying, let's consider this question number 1. So here we have the question number 1. How do we solve this question? This is the velocity time graph now. And the question says, calculate the acceleration of the body, the total distance covered, the retardation of the body, and the average speed. Now, for acceleration, we know that acceleration is the change in velocity all over time. Now let's see. This is a velocity time graph. That is, we plot velocity against time. If you look at the body starts from here and ends up here. This is the initial velocity and here is the final velocity. Are we together now? So, the final velocity is 15 meters per second. So we have 15 minus the initial is what? 5 divided by the time. The time that takes this body to accelerate. That is, it moves from here down like this. It accelerates. When the body gets to this place, from here to this place, it's moving with a constant speed. That is a constant velocity. And when the body gets from here, you can see that it retards back to what? To the starting point. So this body retards here. This is retardation. As the graph is coming down like this, retardation, this is what? Constant speed. And this is when the body accelerates. Let's get this at all time. Okay? So the time that takes the body to accelerate is from here down to this place. So if you trace it down, it's missing in the question. Let's just form it. Let me put this as 5 seconds. Let me put this as 10 seconds and put this as 15 seconds. Okay? So this is going to be 5. Are we together now? So this is going to be 10 divided by 5. So that will be 2 meters per second square. It's as simple as that. The second question, the total distance. Total distance covered, remember, is going to be the summation of what? The area of individual shape. When you look at the first shape, this is what? A trapezium. That is, I label this A, I label this B, and I label this C. Shape A is like a trapezium. And shape B is what? A rectangle. And shape C is what? Is a triangle. Are we together? Or in a nutshell, I can just like consider this shape to be what? A trapezium. but don't let us go there yet for better understanding. So let's see. This is what A, which is a trapezium. So the total distance covered is going to be 1 over 2 h into A plus B, then plus a rectangle, length times breadth, plus a triangle, 1 over 2 base times height. So the total distance covered is going to be 1 over 2 times the height of this is going to be the height of this is going to be this from here to this place. That's 5. Remember, this is the height. Are we there now? So that's 5 into from here to this place is what? 5 plus from here to this place is what? 15. Are we there now? Then plus the length and the breadth of this. The breadth of this is the length of this is 15 and the breadth is what? 5 plus 1 over 2. The base is 5 and the height is 15. So the total distance is going to be 1 over 2 times 5 times this is going to give us what? 20 plus this is going to give us 75. 5 times 5, so that's 75 plus this is going to give us 75 all over 2. So when we add everything together, we are said to have 162.5 meter. So do we get this now? So that is the total distance. So the next thing now is retardation. Now I told you the body starts retarding from here. Now retardation is also this, but our V is going to become what? 0. Because the body starts retarding at final velocity. So our final velocity is going to be what? Our initial velocity. So A now is going to be what? Negative U. So which is 15 all over. The body starts retarding from here down to this side. That's 5. And that will give us negative 3 meter per second square. So that is our retardation. And what's the next thing they ask us to calculate again after retardation is what? Average speed. So we're looking for average speed. What is average speed? Average speed is given as the total distance all over total time taken. So average speed, our total distance now is going to be what? 162.5 meter divided by the total time from here to this place. That's 15 seconds. So our average speed is going to be so 162.5 divided by 15, so that's 10.8. 10.83 meter per second. So do we get this now? So that's how to go about that. So let's look at another question on it. So question number 2 tells, this is the diagram we are given now. This is a velocity time graph. So the question now says, the diagram above represents the velocity time graph of a body in motion. The total distance traveled by the body is 195 meters. Calculate the acceleration of the body in section OP of the graph. This is the section OP of the graph, and that's the only time the body accelerates. Because PQ, the body is moving with a constant speed. Q, O. Okay, can I call this O? Okay, let's give this one R. So the body moves from Q to R. Are you getting this now? It's decelerating. So we are asked to calculate for the acceleration of the body. How do we go about that? The first thing we need to think of is how we can get to what? The final velocity here, because we already have the initial velocity to be 0. but we can do that. Since we are given the total distance, Abi, and we know that the total distance can be gotten by adding the area of individual shape. This is a trapezium, Abi? Yes, it's a trapezium. Let me just use the formula for the area of a trapezium. Then I think we'll get it up. Yeah. Okay, so that will be 1/2 times the height. This height is going to be the final velocity. Then times the summation from here to this place. That's 11 minus 6, that's 5. Multiply by 0 to this place, that's 21. Sorry, addition. So the total distance, is given to be 195, and this will be 1/2 times v times this will give us 26. So 2 here 1, 2 here is going to be 13. So 195 is 13v. So v is 195/13. So v is going to give us what? 195 divided by 13. So that's 15 meters per second. Okay, so if you like, you can just do the summation of what? Area of this triangle plus that of this rectangle plus that of this triangle. You should end up with the same result, 15 meters per second, because this shape is also a trapezium. Is that taken? Okay, so the acceleration is v minus u over t. So we have 15 minus 0. The time that takes the body to accelerate is just what? 6. And that will give us 15/6. So 15/6, that's 2.5. So the acceleration is 2.5 meters per second square. So do you understand this now? Okay? If there's any question you want to ask, you are free to ask in the comment section. Okay? I would have loved to look for more examples on this. But X-wise, I'm getting weak already. So please pardon me and let me go now. So if you have any question you want to ask, especially on some questions that will be given to you, and they will ask you to use those questions to form a velocity time graph. I wish to look at that, but probably in our next video, we might consider miscellaneous questions on this topic. But periodically, you have to look for more questions on it. Do have a lovely day. Don't forget to subscribe and share with your friend. Thank you.